Okay, so now that we can graph complex numbers, we need to take the next step and we want to figure out what is the absolute value of a complex number. So we really need to go back and think about what absolute value is. When we took the absolute value of a regular number, a whole number, or an integer of some kind, and then we said like the absolute value of -4, the definition of the absolute value is what is the distance that -4 is from 0 on the number line. And so if we counted from 0 to -4 on a number line, we'd find out that it's actually 4 units away, which is why we'd spit out a 4. Okay? And that's the definition of absolute value. It's not just sign changing or making things positive. It's actually measuring, and it's saying what is the distance from 0 on the number line. So if I apply that same idea and say we have this complex number, what is 3 plus 4i? So let's graph that real quick. I'm going to go over 3 because that's a. That's my real number. And I'm going to go up 4 because 4i is my complex number. And I'm going to say this point right here, 3 plus 4i, that's the graphed point of my complex number. So what I'm really wondering when I put the absolute value of 3 plus 4i is if I went from the origin to this line right here, I want to know how long is that line. We want to measure the distance from the origin to the point that we just graphed. And so I'm giving you a little shortcut here. This is really the Pythagorean theorem. If you notice, if I did like c squared, right, and I got rid of this radical, that's your Pythagorean theorem. And so that's really what we're doing. We're kind of measuring, and we're saying if I start at 0 and I counted blocks this way, there would be 3 of them. 1, 2, 3 blocks gets me here. And then if I were to count up, I would count 4 blocks, okay, to get myself up there. And I'm really doing like a Pythagorean theorem distance formula kind of problem to figure out how long the line is. So that's what this formula that I'm giving you to calculate the distance, that's where it comes from. We're really just using the Pythagorean theorem to help us figure out how long the diagonal line is, which we can't measure directly. So for this particular problem, I'm going to say the a value is the 3, so it's 3 squared. The b value has nothing to do with the I, it's the number that's in front of I. So I'm going to say that's the positive 4, so it's 3 squared plus 4 squared. And I'm going to put a big square root over that. So I'm going to say 3 squared is 9, 4 squared is 16. 9 plus 16 is going to be the square root of 25. The square root of 25 is technically 5 and -5, but we're not going to count -5 because we're measuring a distance. We're measuring how long something is. So I'm going to say the absolute value, which means the distance that this point, 3 plus 4i, the distance that it is from 0, from the origin, is exactly 5 units. That's what we calculated. So we can really just use this formula. Anytime that you're asked what the absolute value of a complex number is, we can plug into the square root of a squared plus b squared, which again is really the Pythagorean theorem. Okay, so here are 3 problems for you to try. Graph them to get some practice with graphing, and also after you graph them, figure out how far they are from the origin. What is the absolute value of each of them? And that's using the formula that I just gave you, the square root of a squared plus b squared.